So problem B in the same problem that we saw from the book gives you molecules in the stick and ball model, or ball and stick model, and we should be able to see the molecule and the chirality center and which groups are pointed towards you and away from you based on what we call the depth perception, right? So let's say you are a person standing here and you're looking at this molecule this way. You can clearly see that the chlorine is pointed towards you, the methyl is also tilted towards you, and this ethyl CH2CH3 is also tilted, and the hydrogen is the only one that is going to be pointed away from you. So the way you should see this is the hydrogen should be in the broken bridge notation, and then the other three groups are going to be essentially projected towards you. So that's the CH3, that is methyl, and then that is ethyl, so CH2 CH3, and the chlorine is here. So if you're standing and looking at the molecule, and that's your line of reference or axis of reference, that is 1, 2 and 3, and as you can see it will go counterclockwise for you, and therefore this is an S centered molecule. So this is also 2-chlorobutane, basically the same structure here given in the ball and stick model. So this is an S molecule. Now what you're going to do is look at the molecule from this angle here, and if you look at it from here, you can see that the chlorine is pointed away from you, but we want to have hydrogen pointed away from us. So I'm going to redraw this molecule, except I'm going to switch chlorine and hydrogen so that the hydrogen is pointed away from you. So the hydrogen is there, then the methyl is projected towards you, for example, or you can even imagine this to be on the same plane. You can draw it with these two groups in the same plane as well, so that'll be a little bit easier, I would reckon. So this is why stereochemistry, there is no one way to approach a problem. The only thing you have to make sure is you are able to see the molecule in three-dimensional space. So either way, so if you are looking at it slightly below this hydrogen here, you will see that the hydrogen is on the top projected towards you. The chlorine, sorry, this is the groups, right? So the chlorine is projected towards you because we switched it so that the hydrogen goes behind, and the ethyl is to your right and the methyl is to your left, and you are the person that is standing and staring at this molecule from that angle, so that the hydrogen, the carbon hydrogen bond is your axis of reference. That is 1, 2 and 3, that is going to be clockwise. So here it's an R molecule, that means this is an S molecule. So this and this, or this and this, right, they are both S centers, and therefore they are identical structures. They are identical structures. Okay, and so yeah, basically if you turn this, if you take this molecule on this axis, flip it in a way so that the chlorine goes behind, and turn it to from your left with the methyl coming towards you, you can basically get the same structure here. And I would suggest you to build a molecular model. Take two different models, build this, and see whether you are able to superimpose them. And if you did it right, you will be able to superimpose this structure onto the other structure, and therefore they are identical molecules.